Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss upcoming videos, subscribe to the channel and turn on the notification bell to receive all updates. Imagine for a moment that you are an explorer of the universe, a curious observer gazing at the night sky in search of clues about distant worlds and the possibility that, beyond our planet, there may exist forms of life capable of breathing, growing, evolving, and perhaps even thinking. Since time immemorial, humanity has asked the crucial question of whether we are alone in this vast cosmos or if, somewhere among the stars, life has blossomed just as it did on Earth. This question has inspired philosophers, scientists, writers, and artists, fueling our imagination and guiding a journey of discovery that today translates into advanced scientific research and increasingly sophisticated space missions. In this great journey into the unknown, the recent discovery related to the planet potassium boride represents a milestone, a turning point that could mark the beginning of a new era in our understanding of the universe and our place within it. The planet potassium boride, an exoplanet orbiting a red dwarf star hundreds of light-years from Earth, has been observed with the James Webb Space Telescope, a revolutionary instrument that has taken astronomical observation to unprecedented levels thanks to its ability to analyze the light emitted or filtered by celestial objects with incredible precision. Through spectroscopic techniques, scientists have been able to probe the atmosphere of K2-18b, looking for signals of molecules that could be clues of biological processes similar to those that on Earth are closely tied to life. Among these molecules, one in particular has caught attention: dimethyl sulfide, or DMS, a substance produced almost exclusively by living organisms, especially by marine microorganisms such as algae and bacteria. The presence of DMS in the atmosphere of such a distant planet is an intriguing element because, if confirmed, it could indicate biological activity, a true signal from another world suggesting the presence of life forms. However, science is a discipline based on solid, repeatable, and rigorous evidence, and every discovery of this kind must be evaluated with caution. There are in fact other possible explanations for the presence of DMS or similar molecules in a planetary atmosphere: abiotic chemical reactions, volcanic activity, or still poorly understood phenomena could produce similar signals without involving living organisms. Moreover, the data collected are often subject to noise, interference, and technical limitations that require in-depth analysis and confirmation through multiple and independent observations. The statistical significance of the presence of DMS on potassium boride, which hovers around a value of 3 sigma, suggests a promising but not definitive result. To speak of a confirmed discovery in scientific terms, a confidence level of at least 5 sigma is required, which drastically reduces the likelihood that the result is due to chance or errors. This makes it necessary to continue with further observations and studies to strengthen or refute this hypothesis, a process that will require time, effort, and new technologies. It is also important to consider the environmental conditions of K2-18b. The fact that it orbits in the so-called habitable zone of its star, meaning a region where temperatures could allow the presence of liquid water, a key element for life as we know it, makes this discovery even more significant. However, red dwarf stars are characterized by strong stellar activity that can heavily influence the atmosphere of nearby planets, exposing them to intense radiation and magnetic storms that can destroy complex molecules or make the environment hostile to life. This complicates the interpretation of data and requires very sophisticated atmospheric and climate models to understand what conditions actually prevail on K2-18b. The search for extraterrestrial life, therefore, is an enormous challenge involving astronomy, chemistry, biology, physics, and many other disciplines, all united by a single goal: to answer the question that has always fascinated humanity. The case of K2-18b is emblematic of this complexity. It represents a first step, a clue that urges us to look more closely, but also with great humility, recognizing that the answers will not be immediate or easy. Every new discovery opens up new questions and invites us to rethink our theories, stimulating the scientific community to work together to improve observation tools, refine interpretive models, and design future missions that can provide even more accurate and complete data. Furthermore, this research reminds us how unique and precious our planet is. A rare treasure chest of life in a cosmos still largely unexplored and perhaps full of surprises. The story of K2-18b also teaches us the value of patience and perseverance in science. A path made up of small steps, doubts, revisions, and discoveries that build over time. The desire to know whether we are alone in the universe is more alive than ever and motivates scientists, engineers, explorers, and passionate individuals alike to continue pushing the boundaries of knowledge, to look beyond the horizon, to imagine distant and perhaps inhabited worlds. The James Webb Telescope, along with other instruments and future missions, will be a protagonist in this extraordinary journey that could one day rewrite our understanding of the cosmos and our place in it. Every molecule detected, every signal captured, every data point collected is a piece of a mosaic that connects past, present, and future, and that may reveal to us one of the greatest truths of existence. That life is not an isolated miracle, but a phenomenon that can emerge wherever the right conditions exist. To fully grasp the scope of this discovery, it is helpful to pause and understand how spectroscopy works, the fundamental technique used to analyze the atmosphere of K2-18b. Spectroscopy is based on the analysis of light. When a planet passes in front of its star, part of the starlight filters through the planet's atmosphere before reaching the telescope. The molecules present in the atmosphere absorb specific wavelengths of light, creating unique spectral fingerprints that scientists can identify. This method allows the detection of water, carbon dioxide, methane, oxygen, and, in the case of K2-18b, dimethyl sulfide. The ability to discriminate these chemical signatures with extremely high precision is one of the greatest revolutions brought about by the James Webb compared to its predecessors. At the same time, the search for extraterrestrial life fits into a much broader context that also involves the exploration missions of the solar system. Robots and probes are studying Mars, Jupiter's moons like Europa, and Saturn's moons like Enceladus, which have subsurface oceans potentially capable of supporting life. These celestial bodies offer complementary opportunities to the research conducted on exoplanets, providing relatively closer locations to search for signs of past or present life. The combination of astronomical observations and space missions thus makes this field interdisciplinary and constantly evolving. Finally, looking to the future, several missions are being planned to enhance our ability to investigate distant worlds. Even more powerful telescopes, both space-based and ground-based, along with new technologies such as high-resolution spectroscopy and biochemical signal detectors, promise to deliver clearer and richer data. The idea of sending interstellar probes, though still distant in terms of time and technological capability, remains an ambitious and exciting goal. One that could one day allow us to directly explore those planets and test in person the hypotheses we currently formulate only from afar. While we await definitive confirmations, the discovery of potential signs of life on potassium boride remains a beacon of hope and an invitation to never stop searching, exploring, and dreaming. Because the future of our understanding depends on how much curiosity and determination we put into exploring the infinite universe that surrounds us. Science is not just a collection of data and theories, but a collective adventure made of passion, imagination, and dedication, in which each step forward brings us closer to fundamental answers about the very meaning of our existence and the destiny of humanity among the stars.